So for the awesome problems, you're just drawing a sketch and then finding the range. So, well, just as sketching. So I thought we did this one. This is 1 over x, except what does 1 over x plus 1 do to this 1 over x? Shifts it to the left. 1, right? Right? And this says x, we use this when x is what to 0? Greater than 0. So I'm going to erase this one. And greater than 0 means I can erase this too. And that. So what 1 over 0 plus 1? 1 over 0 plus 1. What is that? 1. Yep. So I got that part graphed. You good with that? I see squints. So I move this over. Let's do it a different way. Let's plug in a 0. 1 over 0 is 1. Let's put in a 1. 1 over 2 is a half. 1 over 3 is a third. Can you see how this nice, graceful little thing is going to appear? All right. Emily, can you see okay? Should I move it up? There we go. Then we're going to graph. That was the hard part. This is the easy part. A is greater than 1, and we're going to say y is equal to a when it's less than. So here is a. But it has to be bigger than 1, so it has to appear above. Could these line up like this? They could. But since this one's equal and this is greater, it's always going to be a little bit above. So the domain for this one, the domain would be all real numbers, because everything here is going to be used. Even at this spot, there is an x value used, 0. The range is going to be quirky. It's going to be a, and then it's going to be y between, I don't think they asked you for this, but 1 and 0. They just asked for the graph, didn't they? Yeah. Don't worry about the range. Yeah. So you put in, see how x is greater than or equal to 0? We put a 0 in, and 1 over 1 is 1.
Right.
Put a. But the x value is 0. X is equal to 0. F of 0 is 1. And then a is whatever you choose it, as long as it's greater than 1. This one? Yeah, can be anywhere. Can be anywhere you want. Let's see where it says a is greater than 1. It has to be above that. You guys are doing great. This stuff is hard. Should we do the part B? Yeah.
Do you know it's a horizontal?
Y equals a. Let's let a equal to 2. Well, what is this saying? It's saying when x is less than 0, f of x is equal to 2. Show me what f of x equal 2 is. That, right? So that's why I get it. I know it looks so weird, doesn't it? Let's try this second one. So you have this is a piecewise function, and we have two things going on. One thing you have going on is this a plus x squared, and you have this x plus 3. Now I'm going to color this side blue and this other side green. What does a plus x squared match to? Blue or green? It's the blue. X greater than 0, that's going to be the blue one. Of course, I colored it green. Nice going. All right, and then the other one's going to be green, isn't it? Does that help a little bit? Because of the domains, they tell you where they are. All right, so show me with your arms x squared. Okay, good. So we're going to draw that. And then plus a. Now a has to be less than negative 2. So that means a value for a that we might have would be what? I like it, negative 4. So this is going to say that if x is greater than 0, x squared, got it, and then a is negative 4, drop it down 4. 1, 2, 3, 4. It also says that where x is greater than 0, which half of this blue line do we use? Left or right? The right. So I'm going to erase the left of it. And I'm just going to put this, I'm going to go down 1, 2, 3, 4, and call it A. Now a little tricky part of this is that this, is it A or negative A? It's A because A is negative 4 and we're adding it. So this is A itself. And then it goes from here and then it goes up, 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 up. This one is just straight. There's no A here. X less than or equal to 0. We're going to start at 1, 2, 3. And then we're going to go like that. Is that all right? Yeah.
Why does it go down, not up?
I love it. That's very cool. So show me what y for x looks like. That's why.
Why can it keep going past because it's less than?
Mm-hmm. Yep. Let's see. This is green. This is blue. So the less than 0 is the green part. Notice that it's y equal x, and then it's moved up 3. And this one is y equal x squared, and then it's moved down a. So we've got our plus a, which is minus, so it goes down. And so that's your shape. So 43, what you're doing with that one is you're trying to find the domain. We don't want the range yet, just to find the domain. So there's two things that we can't do. We can't divide by 0, and we can't take the square root of what? A negative number, okay? So all you have to do is say, all right, if this is some function here, this function can't be equal to 0, and this one has to be what to 0? Greater than or equal to 0. Those are the two implicit considerations for domain that you can make. You can look at any function and make that decision. Can't divide by 0, can't take the square root of a negative number. So what's going to be the issue in number 43? Can't divide by 0 or the square root of a negative number? What's the issue? Can't divide by 0. So you want to see where x squared minus 36 can't be equal to 0. So x squared is not equal to 36. What are the two values x can't be? Negative 6 and 6. So there's your domain. If you want to, you could write it this way. Negative infinity to negative 6. Union negative 6 to 6. Union 6 to infinity. Which way do you like better? Do you like this way, or do you like the blue way? I thought you would. Yeah.
But in the first one, could I write all real numbers except for negative 6?
You sure can. I love it. That's great too. All real numbers, and you just go like this, not equal to negative 6 and 6. Mm-hmm. Yeah. 41. So what's the issue with this one? Can't divide by 0 or square root of a negative number? Can't divide by 0. Now look what happens when I go x squared plus 3 cannot be 0. X squared is not equal to negative 3. Can you take the square root of negative 3? No. So this means that all reals are going to work. Negative infinity to infinity. Think of it this way. Is there a number you could square at 3 and get 0? Why not?
Because nothing squared will make it negative.
Any negative squared is going to be positive. So even if you took like 0.000001 and squared it and added 3, it's still going to be positive, right? But if you took a negative 0.001, it's still going to be positive plus 3. If you took a negative 10 squared is 100, well, that's definitely not. So does that make sense? Yeah, question?
Oh, I figured it out.
Cool, great.